Hello students, welcome to experiencetutor.com. Today we'll discuss solid state part 3. And this is your welcome message. Therefore, in the last class we have studied about unit cell. So let us again revise it. So what is unit cell? The smallest repeating unit in space lattice, which when repeated over and over again in different direction produce complete crystal lattice. So it is the smallest part, smallest portion, and which is from which crystal lattice is made up of. So there are two important parameters in unit cell. First is edge length or axial distance. So two important parameters are edge length or you can also say axial distance. So what is edge length? It is the length or dimension along the three edges A, B and C, which may or may not be mutually perpendicular. Fine. So what is the next parameter? It is interaxial angle. Next parameter is interaxial angle. So what is interaxial angle? It is the angle alpha, beta and gamma between pairs of edges. So if we draw the x-axis, the y-axis, x-axis and z-axis in such a way that now if we draw here So this is our x-axis, this is our y-axis, and this is our z-axis. Then if we keep this as A, this as B, and this as C, where, and this is the origin O, where OA is equal to A, OB is equal to B, and OC is equal to C. And angle between axis B and C is alpha. So here this is alpha, and angle between A and C is beta. So A and C, this angle is beta, and angle between B and A is gamma, or A and B is gamma. So this is gamma. So this angle is gamma. I hope this part is clear. What is unit cell and what are the parameters of the unit cell? Good. Now let us go to the next topic. Next we have learned about type of unit cells. So there are two types of unit cells. First is primitive unit cell. So first one is primitive unit cell. First one is primitive unit cell, and second one is non-primitive unit cell. So let us understand what is primitive unit cell. So it consists of only 8 lattice point or constituent particles at 8 corners only. So constituent particles can be molecules, atoms, ions, anything. Good enough? So 8 lattice point at, or constituent particles at 8 corners only. Non-primitive, or this is also known as centered unit cell. So non-primitive or centered unit cell, what is it, and we should know more detail, though we have studied in the last class, but I am giving more emphasis to this topic because this is very important. Solid state is based on this. It consists, so non-primitive or centered unit cell, we can define as it contains one or more lattice point at other than 8 corner positions in unit cell. So there are lattice points in 8 corners, but beside that it also contains lattice points. So we can divide non-primitive or centered unit cell into 3 types. First one is body centered. Body centered unit cell. Second one is face centered unit cell. And third one is end face centered unit cell. Now let us go in detail about each type. So what is body centered unit cell? There are 8 lattice points at 8 corners and one additional lattice point at the center of the body. Good, fair enough. What is face centered unit cell? There are 8 lattice points at the corner and 6 more lattice points at the center of each faces. Very good. Now what is end centered unit cell? There are 8 lattice points in the 8 corner and one constituent particle is present at the center of any 2 opposite faces. So we can see here the first one, the primitive or simple, where 8 corners contains 8 lattice point, and second is body centered, and third one is face centered. So 7 crystal systems. After taking the axial length, that is A, B and C, and interaxial angles, that is alpha, beta and gamma, into consideration, various crystals are divided into 7 types of crystal systems, also called crystal habits. We will study in detail about these things. Okay, let us see the first crystal habit, that is cubic. This one. So For cubic, all the sides are equal. A is equal to B is equal to C, and all the angles alpha is equal to beta is equal to gamma is equal to 90 degree. Yes, very easy to remember. Now we'll see tetragonal, the second one, this one. For tetragonal, two sides are equal. A is equal to B is not equal to C, and all the three angles is 90 degree. So we can write alpha is equal to beta is equal to gamma is equal to 90 degree. The third one is orthorhombic. Here none of the sides are equal, so we can write A is not equal to B is not equal to C, but all the angles are 90 degree. So alpha is equal to beta is equal to gamma is equal to 90 degree. So we have discussed this one. The fourth type is monoclinic. Here all the sides are not equal and two angles are equal to 90 degree. So this one, all the sides are not equal. So A is not equal to B is not equal to C, and alpha and gamma, alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. Now hexagonal, here also two sides are equal and two angles are equal to 90 degree and one angle is 120 degree. So two sides are equal, we can write A is equal to B is equal to B and not equal to C. And in terms of angle, alpha and beta is equal to 90 degree and gamma is equal to 120 degree. This one, this angle 120 degree. So next, rhombohedral. Here all the three sides are equal and here all the three sides are equal. So A is equal to B is equal to C, but none of the angles are equal to 90 degree. Alpha is equal to beta is equal to gamma is not equal to 90 degree. And the last one is triclinic. So triclinic, none of the sides are equal. A is not equal to B is not equal to C. Alpha is not equal to gamma, not equal to beta is not equal to gamma, is not equal to 90 degree. So these are the 7 crystal habits or crystal systems. And this is the end of today's topic. Please subscribe our channel and click the bell icon for notification. Please like our videos and give comments what you liked and what you didn't like. We'll try to improve ourselves. Thank you for watching our course.